Very happy to be here to talk about AI and data centers. There's no shortage of discussion around AI these days, but this will be a little bit of a different spin because a lot of the industry and a lot of the users of AI just think that AI is going to magically appear, but it is massively disrupting how the data center operators are building, designing, building, and deploying data centers from an IT, a power, and a cooling perspective. And that's going to be what we're going to talk about today. So there's two different types of AI deployments. There's the deployment where you are training these large language models, and then there's deployments where you're taking a version of that large language model as a compressed model and deploying it in the field to do actual work. And most people are talking about the LLMs when they talk about AI from a data center perspective. And when you're talking about training a model, you're taking a snapshot of all of the parameters that you think are going to be useful at a single point in time. But these parameters could be billions or hundreds of billions of data points that you're trying to put into this model so that it could learn. So these are being done mainly in the very, very, very large data centers. Inference, when you have a model that's working, you can move that model to the field to do actual work. Here we show it doing different applications like intelligent machines. So you can deploy the compressed model of your LLM, and you can have it do things like look at the maintenance of those machines. You could take videos of all of your different robots and machines and do predictive analytics. You can also use it to integrate and do different types of predictions with your manufacturing capacity, your supply chain, what to build. So you can integrate systems like your manufacturing execution systems with your CRM and your ERP, and you can like automate all of your supply chain by understanding what the demand is in the field versus what you're building. So it really optimizes things like supply chain. Same thing, we show self-driving cars. You could use AI for things like emergency vehicle routing, for example, to help understand, the best way and route the emergency vehicles to traffic. And then there's the generative that most people are familiar with. That's asking the model a question and have it return a result. So where these models are deployed, I said that the LLM training is usually at a large central core data center. The working models are going to be deployed closer to the users and the data in the field. So we're seeing this happen first at a regional basis, and eventually we're going to see these go in the very small data centers, very, very close to the users. So if you're running something like a working model, say it's for security, for a facility, and you're using AI to do, predictive decision making and securing either a cybersecurity or physical security, you can use AI for both. Obviously, you would want that data center, especially if you're using like video, high definition video, to be located locally. So we're seeing a move. Once the models are developed, we're going to see a move to regional and then eventually to local data centers. So what's the difference? Why is this so disruptive? And the big reason it's disruptive is because the servers that we're using for AI training. So a traditional, hyperscale or server farm or data center, whatever you want to call it, uses very standard two-socket x86 type of servers. There's some variations, but most cases they're very much the same. They're usually around 2U. Some of them are 1, some of them are 4U. They pull about 3 to 5 kilowatts. But this model does not work when you're training AI data. And the reason it doesn't work is because you're using the CPU for everything. The new way to process large amount of data is with servers that they do have CPUs, but they have CPUs to manage the GPU accelerators. So each one of these servers will have a bunch of GPUs, usually 8, but there's been new servers that were just announced that have 16. Some of them have 32. And the way that these work is all of these GPU accelerators operate in parallel to crunch the data. So not just within the server, but all the servers that are working together within a cluster are all operating in parallel. So that's the way they can process the tremendous amounts of data to be able to train the models. They also have things like DPUs, which are data processing units, to help manage the data flows in and out. So each one of these GPUs actually has its own network connection. So when you're deploying, a regular server, it'll have one network connection per server. So if this one has, 8 GPUs, it'll have, 8 network connections. So all of these GPUs and servers operate in parallel. So AI as a percentage of the data center workloads is, depending on your point of view, either very moderate or very large. So about 8% of the workloads we estimate in all of data centers, inference and training, are used for AI. So AI is being used for things like chatbots and predictive analytics, digital twin modeling, things like that, already. We expect it to grow, very fast, and we predict that it's going to grow 3 times the rate of normal data centers, which are also growing very fast. So we're seeing that AI as a percentage of data center power consumption to go from 8% today up to 15 to 20%. And we're going to see a move from the more centralized, training AI to more of the edge AI. Moving closer to the users and the data. And why when you're training a model do you have to deploy them in these high density clusters? Well, you don't have to, but it makes things a lot more challenging from a connection perspective of the different servers and GPUs. So all of these servers and GPUs, like I said, were operating in parallel. So the farther that you put them apart, the harder it is to get them to operate together. So you're seeing these AI servers being deployed in a very high dense application, or a cluster, as they're called. And the communication fabric that's being used is 400 gig, or now it can go up to 800 gig. Last year, most data centers were 20 or 40 or 60 gigs. So the expense of the fiber and the speed of the fiber goes up proportionally. So the faster it is, the more expensive it is. So you can't just have one server per rack and air cool it, for example, and then spread out the load across an entire data center. So the data centers are going to look a lot different when they're being used for training AI. They're going to be densified. So you're going to see maybe a data center that was 100 racks, 10 kilowatts per rack, or 1 megawatt, go down to 10. That's running 10 racks at 100 megawatts. So it's a big challenge, not only to get the communication cables, but also the power cables, because these servers are using multiple power supplies, and each power supply needs a power connection and then a redundant power connection. And then you have the piping for the cooling if you're using liquid cooled. So these are all big changes that are turning the kind of the data center architecture upside down. And this is just an example of what a cluster would look like. Like a one rack could go up to 100 kilowatts per rack, and then a small cluster with 4 racks would go up to 400 kilowatts, and then the megawatt one, this one's showing 8 racks. So the other thing I should mention about the differences is when you were designing a data center, in the past, the workloads tended to be dynamic and variable. When you're training a model, the workload is going to run very, very close to capacity, and it's going to run at capacity continuously. So if you have this cluster of 8 racks and it's running at 1,000 kilowatts or 1 megawatt, it's going to run at that 1 megawatt continuously. So there's going to be no buffer in the design in non-AI types of environments. You can design it for 10 kilowatts per rack, and it many times will be running at 4 kilowatts per rack, and it'll peak up to 10 kilowatts per rack very, very rarely. The difference with AI, like I said, is that it's going to run at capacity. So the days of having this built-in buffer are going to be over with AI models. And this just shows you an examples of liquid cooling and the connections that are required. So there's different ways to do liquid cooling, and liquid cooling can bring the liquid all the way into the chip, or it could do things like this rear door heat exchanger that we're showing that brings liquid to the back of the rack, and it rejects the maximum amount of heat to some kind of heat rejection that's usually outside, a chiller, or cooling tower, something like that. And then to manage all of the fluid that's flowing through these different systems. So you'll have different systems going in and out of the servers. You'll have systems of loops that are taking the hot liquid and rejecting it to cold through some kind of buffer, and you'll have manifolds in cooling distribution units that you didn't have before. So each rack will have a manifold for the connections, and then you'll have a control system, which is called the cooling distribution, which controls the flow of the water or the liquids going around the different systems. So it's a much different type of system. The benefits are that it is more efficient than using just air systems. So AI driving massive growth of all sizes of data center. It's going to start with the large training models. The physical infrastructure is going to be disrupted on power, cooling, power distribution. The racks I didn't mention, but the racks are going to be much different because the servers are much bigger, they're much deeper, they're much heavier. So the racks are going to have to change, and even the floors, if depending on how you deploy it, you may not be able to, maybe just too much of a concentration of weight for a raised floor. And then the next big challenge is deploying, very, very large scale inference at edge. So, and doing everything in a sustainable way, which is going to be really important going forward.
Thanks, Steve. Actually, it's great that you've sort of summed up on that point, because we've got a question that I'll ask first from the audience. With the increased energy consumption by AI-driven data centers, what approaches are being implemented to ensure sustainability and reduce the carbon footprint? And obviously, this is something that's come up multiple times today, and I'm sure will come up again over the next 2 days. So it's gonna, we're gonna need this extra power to power this increased capacity. So how is that going to look from a sustainability point of view?
So from a sustainability point of view, there's certain things you do on the supply side and also on the demand side. On the demand side, we showed the liquid cooling. It's actually the denser you deploy it, there is an opportunity to actually make the cooling systems more efficient. So bringing different types of liquid cooling, into the chip, direct to chip, types of cooling, really improve the efficiency of the cooling systems. And with the continuous workloads, because they're not variable, you could use things like AI to actually model the water temperature or the liquid temperature or the flow rates, and you can change them, and you can have AI kind of deliver like the most optimal configuration for your cooling systems, which was really impossible if you're dealing with thousands of set points.
Yeah.
If you're doing it with AI, the machine can do it. It can vary them all, and it can run different tests, and then it can figure out what is the most efficient way. But by and large, the biggest benefit is powering these data centers with renewable power sources. So that's the key. As new data centers are being constructed, a lot of the permitting, is requiring them to actually, have a source of renewable power before they're able to construct it. So there's lots of distributed capacity that's coming online in wind and solar, and there's a lot of work being done on the grid management side, and we're doing a lot of work to be able to source the most renewable or sustainable power source, to power the data centers, as an operation parameter. So there's a lot going on the sustainability front with data centers, as we're adding more capacity for AI.
I suppose it's something that you always have to take into consideration now in the design process. And given that obviously we're going to have all these challenges facing us because of these higher density racks we're going to need, what challenges and what upgrades are sort of legacy sites going to need to be doing to facilitate these loads, and what's it going to look like for the data centers at the edge and the data centers that we're going to be building to accommodate this new kind of compute?
Yeah, those are a couple of questions in one, but well, we'll take the edge, and I talked about compressing the models, and there's different ways to compress the models. And when you compress the models to actually perform the work, you have to take into account, the urgency or the speed that you need the decision, the accuracy of the decision. There's not a lot of people talking about this, but a lot of these AI models, sometimes, don't deliver the most accurate solutions, and that's because they're being processed through a compressed model that may not have all of the information. So you have to take into account the accuracy, the speed, the latency. So the models that you're going to deploy in the field, depending on the application, could be very minimal. If you're looking at some kind of generative AI to do like a book report, you don't need that response, right away. And you don't need it to be like the most accurate. But if you're running like an electrical grid and delivering power to different, and you're making decisions, immediately, you're going to want to deploy, a beefier model, in that application. So. But there's all kinds of work being done to look at how to make these systems the most efficient and accurate as possible, while training and also deploying at the edge. We're not involved with a lot of those, but a lot of the companies that are looking at the algorithms, looking at the transformers, and looking at the data sets. So, if you're taking a snapshot of all of the parameters, there may be millions of instances of the
Hmm.
same data point. And do you really need all of those, or you just pick one, as part
Yeah.
of your model? I liken it to like people are taking a picture or a video at a concert. You have 10,000 people taking the same video. Do you want your AI, training model to look at every single video from every single person? So you'll just there's work to be done to like eliminate a lot of the redundancy in the training so that it's more efficient.
We've just had a flurry of questions from the from the audience. If you don't mind, I'll jump to those now. So the first question is: how is the geographical location strategy for data centers changing in response to AI's requirements, and what factors are now considered critical when deciding where to build new data center facilities?
Oh, that's a great question. I've actually been doing a lot of work on this because the demand is, like I said, very high, and yet you want to correlate it with where there's planned
Hmm.
increases in power capacity. And
Hmm.
you have places like Europe that we're going through the transition, and many of the countries in Europe to more renewable supplies that came on a little bit slower than they were anticipating. So there's countries that are a little bit starved for power right now. So there's also issues in the U.S. because you know they've really focused on the tier one types of sites like Data Center
Hmm.
Alley in Chicago and Dallas. So, but there's in Northern California, but there's needs to build in different other areas. So what's
Areas.
happening is the planning for a lot of these larger training clusters has been going on for years now, so that we have been matching up the demand with the generation capacity.
Hmm.
And like I said, there's no one used to talk about data center permitting, but data center permitting is a really big deal in a lot of countries, and the
Hmm.
countries like Germany have different regulations now to get the permits. They have to be very, very efficient data centers. They have to use a certain percentage of the heat. So for the next couple of years, the next 2 or 3 years, all the data center capacity on the large scale systems has really already been, in the planning process for years. So we see that as rolling out. After that, it's anybody's guess. There's a lot of money being spent by different government agencies to accelerate the
Hmm.
production of more renewable power. So it's a great question, and there's a lot of moving parts depending on
Yeah.
the specific country and the specific application. There are instances where these plans have been canceled due to the fact that the available power wasn't built as planned, or delayed because the power hasn't become online as planned. A lot of countries are revamping their process for connecting to the grid. So
Hmm.
you had in some countries in Europe, 5 to 7 years of waiting to you were in a queue to connect
Yeah.
your
Yeah.
power source to the grid. So they have new processes for that to accelerate that as well. So things are kind of coming into line to match up the capacity with the generation.
And
So
how big of a part do you think will be incorporating renewable energy sources in there? Because obviously we're going to need increasing amounts of power.
yep,
So.
yeah, it's almost all going to be renewable sources that are being built. Obviously, there's very, very little. Um, planning in most countries for any kind of fossil fuel generation. So it's all going to be, renewable. It's all going to be renewable, and there's also going to be amount of grid storage that's going to be added to a lot of this capacity. And it's a little bit complicated, but um, you know, you don't need 100% capacity for heating and cooling and homes and businesses, 100% of the time. So you have to take a holistic look at the utility from not just capacity, but also storage capacity. So there's storage capacities being added to a lot of these grids that are going to be able to supplement, during peak demand. So it's a little bit more of a complicated scenario than, you have this much demand and this much capacity.
Yeah. And how will that look in terms of space utilization, and making sure that we're using a small amount of space in the best possible way?
The space utilization for the data centers, or
in terms of we're going to need more room for cooling, more room for racks. So how are we going to in potentially a smaller space, especially at the edge? So what's that going to look like?
Yeah, it's going to look different. I think, I gave the example that everything is going to be more compact. So as you move to more powerful servers that are going to be more concentrated, the physical facilities are going to be smaller.
Yeah.
So these large warehouse type looking buildings, may look more like, regular types of buildings in the future.
And just jumping quickly I want to make sure I get these questions in before we run out of time. Just jumping quickly to a question from the audience. There are worries from outside the industry regarding energy consumption of data centers. There are protests at Data Center Island in the UK. And we're seeing the need for a more active role from National Grid to manage the availability of electricity so we don't have widespread blackouts. How does the data industry deal with these issues, especially with AI consuming even more power, to ensure better public image so they're not blamed for being a burden on the grid, which is, again, something that's sort of been an overarching topic for today, and two, ensure that if there is a power outage, they can retain availability?
Well, it's a great question. And data centers, because they're critical facilities, have designs, and most of the larger facilities have designs to operate for extended periods of time on longer term backup. So they have shorter term backup with UPSs and things like that for a few minutes, but they also have emergency standby generators. And these generators could be, natural gas or diesel. So data centers designs right now are looking at the availability of the grid, and they're actually designing more backup systems capacity than they have in the past. So there's going to be more of a cooperation of data center operators and utilities, because data centers, some of them, are, a substantial load on the grid. There's going to be coordination and collaboration between kind of the utilities. Like if there is a planned blackout, the data center operators, will coordinate with the utilities, and, they'll go on, emergency supply. And when they go on emergency generation supply, if it's diesel, there are things like biodiesel, which lowers the carbon emissions. Then there's green diesel, which is HVO, hydrated vegetable oil, which is basically reused vegetable oil, which is also gives you zero tailpipe emissions. So if you're running your generators, which are, if it runs on diesel, it'll run on HVO. If you have a supply of HVO, it'll run pretty much, carbon free, during those times. But there's going to be, collaboration of, like I said, the utilities with the data center operators to kind of manage the capacity if needed. So I think, there was some mention of this in some of the press, and it was quickly squashed because it was, people thought, oh,
Yeah.
they're going to run on diesel, so it's going to be, it's going to be bad. But they are taking steps to operate in a more carbon friendly way. But you're right. It's definitely an issue, and nobody wants the data centers to take up the power that would be used for the heating of their homes or the cooling of their homes. So there's definitely going to be more and more collaboration and even automation of running on different sources. And data center
Hmm.
operators are also, I talked about the grid adding energy storage.
Hmm.
Data center operators are also looking at adding energy storage. So if they put in a certain amount of 2-4 hours of energy storage, data
Yeah.
centers will also, instead of the utilities um, curtailing their generation when some of the renewables may not be needed, they'll continue to provide the excess renewable supply, and the data center operators will store it in
Hmm.
their on-site storage. So they could also use that for peak shaving and demand response, on their own site, or they could
Yeah.
even put that power back into the grid.
Thanks, Steve. Just to sort of jump back to the diesel generators, we've had a question asking. You mentioned diesel genset backups, which has been the mainstay for years. Could hydrogen or battery energy storage be a reliable replacement
Yeah.
to ensure net zero? So, yeah.
Yep. That's the plan, and I think the
Hmm.
technology is there for fuel cells.
Hmm. Yeah.
There's issues with there's different types of fuel cells, but I think the reliability is there now, and the efficiency is definitely there when they're new. There was issues with them being less efficient, but the biggest
Yeah.
the biggest challenge is, of course, the source of hydrogen. You can get
Hmm.
obviously you can get hydrogen now, but is it as green as it needs to be? And as more renewable supply comes online, and we have um, more plants to be able to convert it from water to hydrogen. It's going to be a technology that has been accelerated. There was a data center already announced in the U.S. in the Northwest that's going to run on hydrogen, a 75
Hmm.
megawatt data center. So things are moving in that direction. It's just we need the electrolyzer capacity, and we need the
Hmm.
renewable power supply to make those solutions green.
We do have one final question for the audience, but just to jump back to that. I mean, that's kind of been around for a little while now, this kind of grid interaction, balancing the grid. But there does seem to be a bit of a slow uptake on this kind of technology. And do you think it's just because we haven't had the sort of reliable technology to do that, or do you think this will start to happen much more quickly over the next few years as we gain momentum to start using these kind of technologies?
Yeah, dealing with utilities has always been a time-consuming process. The technology is definitely there, and it is accelerating. As we sit here. So I think you're going to see more of that. I mean, you talk to the utility providers, 3 years ago, they were just happy and everything was stable, and then all of a sudden they're having to incorporate all this renewables. So they weren't exactly happy about it, but because everything was operating pretty well and reliable, but things do change. So
And then just one final question, if I may, from the audience. Is there any such thing as a sustainable data center, as all facilities will always have a carbon footprint? How important is measuring this footprint accurately? And what is Schneider doing to assist partners with this in order to mitigate the carbon intensity of sites?
So a lot of people may not know this, but Schneider actually has a very, very large sustainability business. So we have over 3,000 sustainability consultants that work with all different industries. And we make it easy for companies to actually gather the data and automate the data gathering across their IT facilities. So that's the first step, is reliably gathering the data. We also work with companies out setting their strategies, getting their SBTI approvals, things like that. So throughout the entire journey, we engage, and there's different types of companies. There's companies that are just looking to comply. There's companies that look to benefit from a business perspective by you know, being able to be included in, green bonds and ESG funds and things like that. And then there's companies that are out to like save the world and, retract all the carbon and water positive and waste, zero. So we help, all of these companies. We have a public agreement with very large, big box stores and Walmart, working with their supplier on their scope 3. So we work with companies on sourcing renewable supply. We work making their operations more efficiently, and also even working with their supply chain to be able to emit their carbon neutral and eventually their net zero commitments. So it was actually a very unpopular move when our CEO announced that we were going to, focus on sustainability as a business.
Really?
About 5 years ago, yes, but it's turned out okay.
Yeah, so I suppose 5 years ago as well, it's quite early on in the whole sustainability buzz thing as well, wasn't it? So I imagine that was quite a hard sell 5 years ago. We're running kind of really close to the wire, so just quickly to sort of finish off your session today. So obviously AI is still very much, I mean, it's everywhere, but it's still very much an emerging thing, and we're not entirely sure what it's going to look like and what it's going to do. But sort of 10 years down the line, if you were to look back, what do you see as the major sort of changes over the next 10 years, and how is the sector going to look now with all the changes that are predicted over the next 10 years? What's it going to look like from a 10-year on perspective?
Yeah, 10 years, it's very, very difficult to predict, but the AI is it's been around for a while, but the technology still is emerging. So I think it's going to become the way that the models are trained and the way that they're deployed is going to become more efficient. And we may look back at the way that we're training the models now and deploying them and saying, oh, what were we thinking? Because IT is going to advance, the algorithms are going to advance. So it's going to be, a world where, AI permeates, just about everything that we're doing. But I believe in 10 years, we've been talking about edge and deploying at the edge. We were talking about it for 5G, for moving the cloud to the edge, all these different applications. But moving AI to the edge actually makes a lot of sense, because a lot of these systems and processes are going to leverage AI and become more efficient. So I think it's going to be a more distributed model of the edge. AI is going to be pretty much everywhere, and possibly in 10 years we don't build these mega data centers, and there's more focus on just the local data centers to do these things.